So good day, grade 8 Makati Science High School students. For our fourth lesson for the fourth quarter, we're going to discuss lesson 28 on secants of circles. Okay, so for this lesson, we're going to be discussing secants of circles, our fourth lesson for the fourth quarter. Okay, so again, what are secants? So they are one of the line segments that you can find in circles. They're free. So you have the tangent, the secant, and then the chord. We're on our second line segment now, and let's try to answer this first problem that we have here. So Ramil is trying to model the movement of a celestial body on a circular shaped orbit that we have here. So this looks like a tennis ball, but this is actually a planet. Okay, let's say for example that's a given planet, and given on the figure below, secants AB. Okay, so secants AB, this secant over here, and AC are in a circular orbit, okay, on point G. Okay, so this is point G here. Okay, there you go. And we're in AB is equal to 14,000 miles. Okay, and BR, this line over here, it's equal to 5,000 miles. Okay, so we will also have another given, CT. CT is also equal to 5,000 miles for this problem. Okay, so for this problem, we're trying to find the measurement of AC. Okay, so what's going to be the measurement of AC? The secant over here, secant AC, and also the measurement of TA. What's going to be the measurement of TA, this line segment here that connects the outer orbit on point G to this planet A. So we also need to find the measurement of line segment. Okay, so that's line segment TA. Okay, so for this problem, as we can see here, we have a point, then an external point, an externally secant point on our given figure. Okay, so if we have an externally secant point and we have two secant lines here, we can say that from our secant power theorem, we can say that the outer part, okay, of this secant multiplied by the inner plus the outer part of the secant, of the first secant. Yeah, so this is for the first secant. So it has to be congruent or equal to the second secant's outer line and the sum of the inner and the outer line. Okay, so let's say for example AV is our first secant. We know that its sum, the total of it, is 14,000. So you can write here 14,000 times the outer part. Okay, so if this is the outer part though, okay, if that's the outer part for this problem, okay, therefore we can say, if that's 14,000, this is 5,000, we can say that this is 9,000, right? Because 5,000 plus 9,000 will give you 14,000. So 14,000 times 9,000 should give us the outer of the second secant. This is the one that we need to find. Okay, for secant CA, we don't know the value of secant CA. So we're just gonna write it, or we're just gonna represent it with X. So AC is equal to X. So that's gonna be X times the sum of the inner and outer of the second secant. So since we know that this is 5,000, CT is equal to 5,000. And this entire line segment is equal to X. Therefore, X minus 5,000 should represent the sum of the inner and outer line segments for segment AC. Okay, and therefore, we have here an equation. Okay, so this is a very important equation for the secant power theorem. Okay, so we're going to use this power theorem to solve for the value of X. Okay, so what's 9,000 times 14,000? We can use our calculator. So that's going to be 14,000 times 9,000, so that's equal to 126 million. Okay, 126, 1, 2, 3, 4, 5, 6 zeros. Okay, times, okay, we can distribute the x here. So that's going to give us x squared minus 5,000x. And based from this equation, we can create a quadratic equation. So this is going to be 0 is equal to x squared minus 5,000x minus 126 million. Okay, so that's quite big. Okay, but for this problem, we're gonna be using the quadratic equation or the quadratic formula to solve for the value of x. So therefore, x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and since we know that the value of b for this one is equal to negative 5,000, so negative times negative, that's just going to give us positive. So that's positive 5,000. Okay, plus or minus the square root of b squared. So b is just negative 5,000 squared minus, okay, let's just extend that a bit, minus 4 times 1. Okay, the numerical coefficient of this one is 1 times negative 126 million. Okay, 126, let's just write m, 126 million all over 2 times a, which is just 1. Okay, so therefore this is going to give us, okay, this is going to give us 5,000. Okay, plus or minus, so what's 5,000 squared? So that should give you 25 million. Okay, and what's 25 million? Okay, so that's going to be 25m. Okay, since this is negative and negative, if we multiply them together, that's going to give us a positive. So that's plus, so it's 126 times 4. So that should give you 504 million. Okay, 504 million all over 2. Okay, so this should finally give us 5,000. Okay, plus or minus 529 million. 1, 2, 3, 4, 5, 6 all over 2. And what's the square root of 529 million, guys? 1, 2, 3, 4, 5, 6. So that should give us 23,000. So therefore, the value of x is equal to 5,000 plus or minus 23,000. Okay, so that's going to be plus or minus 23,000 all over 2. And if we're going to simplify that, let's simplify it over here. So that's going to give us, again, 5,000 plus or minus 23, 1, 2, 3, divided by 2. Okay, yeah? And therefore, this should give us 28,000 divided by 2, or it could give us negative 18,000 divided by 2. And just based just from these two values, x sub 1 and x sub 2, we can already say that x sub 1 is going to be our answer because it's a positive root. As compared to this one, this is a negative root. Okay, so therefore the value of x is equal to 14,000, and since AC is equal to x, therefore AC is going to be equal to 14,000 miles. And since okay, so we've solved for AC, since TA is equal to x minus 5,000, so that's just gonna give us 14,000 minus 5,000. So therefore TA is just equal to 9,000 miles. Okay, and that's how we solved our problem for this one on secant power theorem.